Welcome back to the deep dive. Today we are getting incredibly specific. We're looking at a single piece of hardware that most people will never see, but it's absolutely critical. It's the NTI PWR-48V-12V1-6A. It's an external DC to DC power converter.
Exactly. And our mission today is really to understand why. Why does this little box even need to exist? And the answer is that it's a critical intermediary. It lets other more sensitive NTI products work in a really challenging telecom environment.
Okay, so let's break that down. What does this box actually do?
In simple terms, it takes a nominal 48-volt DC input, which is common in telecom, and converts it down to a clean, stable, plus 12-volt DC output.
Capable of handling a 1.6 amp load, which is pretty respectable. But I'm guessing the real trick isn't just the conversion itself.
No, not at all. The trick is surviving the input. A telecom power environment can be notoriously hostile.
Hostile how?
Well, this converter isn't built for a perfect 48 volts. It's designed to handle a huge range, from as low as 18 volts all the way up to 72 volts DC.
Wait, 18 to 72, that's an enormous window. Why so wide?
Because those 48-volt power rails are often really dirty. You get huge sags when heavy equipment kicks in or spikes. This thing just eats it up and provides that clean 12 volts regardless.
And there's another flexibility feature here I noticed. It takes either positive or negative polarity input. That seems really important.
It's huge.
Yeah.
You can't wire it backwards. I mean, you can, but it won't care. It just adapts. It prevents a simple mistake from, frying thousands of dollars of equipment downstream.
So to protect that downstream equipment, there have to be some serious safeguards. The specs mention isolation up to 1.5 kilovolts.
Yes, and that isolation does two things. First, it's a massive safety feature, obviously, but it also stops electrical noise and transients on that dirty 48-volt line from corrupting the clean 12-volt output.
Right, so it's about signal integrity as much as safety.
Exactly.
Okay, you can really tell this isn't consumer grade when you look at the durability specs. I'm looking at the mean time between failures, the MTBF. It's 167,854 hours.
Yeah, and that number can sound a bit abstract.
It does.
So let's put it in perspective. That is over 19 years of continuous 247 in operation.
19 years. And I assume that's not in a cozy office.
Not at all. Look at the temperature range. It's rated from minus 13 degrees Fahrenheit up to a blistering 158 degrees.
So it's made for a metal cabinet sitting in the sun or a remote utility shed in the winter.
Precisely. And it does all this while operating at about 80% efficiency, plus or minus 5%. So it's not wasting a lot of that power as heat, which is also critical in a sealed box.
Okay, so let's get physical. It's pretty compact, right? Just over 3 inches long.
Very compact. It has to fit into tight spaces.
And the connections. Why a 3-pole detachable screw terminal for the input? It seems a little old-fashioned compared to a simple plug.
It's all about reliability. A screw terminal gives you a rock-solid, vibration-proof connection. You can't accidentally knock it loose. For the output, though, it's just a standard DC power jack, which makes sense.
And it comes with a 3-foot cable, which is helpful.
Right.
Now, for you, the listener, let's put this in commercial context. The price today is $175. It's got a 2-year warranty, free shipping in the U.S. But more importantly, it has CE and RoHS approvals, and it's TAA compliant.
And that TAA compliance is a really big deal. That means it's approved for use in U.S. government and military installations. It tells you exactly who the target market is.
So what's the big picture here?
The big picture is that this little unassuming box is a rugged, highly specialized bridge. It's the component that lets modern, sensitive equipment integrate safely into these standardized, high reliability, but electrically unstable power grids.
Which brings us to our final thought. This device costs $175 and it's rated to run for almost 2 decades straight. So here's something to think about. What are the hidden economic or safety costs of a power failure in a critical system that makes this level of reliability at this price not just an option, but an absolute necessity? We'll leave you with that until our next deep dive.